So now let's look at an example question of pulleys. So big one, small one, and then the rope under tension. And we'll say the first one has a diameter of D1, second one has a diameter of D2. And the first one is spinning at RPM 1, whatever that value is. So this is what we have to describe this right here. So it's spinning at this value RPM 1 and it has this value of a diameter. Now we'll do the same for the second one. RPM 2 and then D2. So we were given from electric class, or if you think about this intuitively, you know that this speed or how fast it's rotating is inversely proportionate to its diameter. It's inversely proportional. So what does this really mean in relation to this question? Well, you got to make sure that when you're dealing with inversely proportionate, things are diagonal from each other. The factors that you really want to consider. So RPM 1 is inversely proportionate to D1, so it has to be diagonal from each other, not across. RPM 2, again, it's across. So let's write RPM 1 over RPM 2. You could have done the reverse, RPM 2 over RPM 1. Doesn't really matter. Still leads to the same answer. So what is that equal to? So, they have to be across. So D2 over D1. This is kind of stepping into the boundary of ratios. Whereas RPM 1, RPM 2, D2 to D1. This time they're inversely proportionate. So D2 goes first instead of writing D1 to D2 and then finding their equivalents. So this is what we have right here. If it turned out that RPM was proportional to something's diameter for the pulley, then we would write RPM 1 over RPM 2 is D1 or D2. It would be across, not diagonal. But that's not the case. So now it's just about adding value. So let's just say the first one is spinning at 10 revolutions per minute and its diameter was 15 centimeters. And the second one, which is this right here, was spinning at 7 revolutions per minute. Or no, let's write 17 since I drew it smaller pulley. This is 2. So what's the diameter of the second one? Well, we have all our values. We just plug it in there. So RPM 1 is 10 over RPM 2, which is 17, is equal to D2, which we're trying to find, over D1, which is 50. You always want to make sure that the units that you're using are the exact same. So this has RPMs. If this was in centimeters and you were given D2 in meters, and then you would have to convert D2 into centimeters or convert D1 into meters. So now this is just a simple case of just isolating D2. So we'll multiply both sides by 15 to get D2 by itself. So you'll have 10 times 15 over 17 is equal to D2 times 15 over 15. So multiplying and then dividing by 15 is just cancel each other out. So you're left with D2 is equal to 10 times 15 over 17. Punch that in your calculator and what do you get? 10 times 15 divided by 17. 8.8. 8.8 centimeters. Well, let's do a quick check to see if this is correct. So the first one was moving at a slower rate than the second one. So then it would have to be a bigger diameter than the second one because the rope is traveling at the same speed always. Like if you take a point on the rope, it will always be traveling at the same speed. So the second one, of course. So another quick way of seeing that this is true is we have RPM 1, RPM 2 is equal to 10 over 17. So what does that give you in the calculator? 0.588. And D2 or D1 is, we found it to be 8.8 over 15. Punch that in the calculator and you get, punch that in your calculator and you get 0.587, which pretty much equal, and this holds true, so you know that you did it right.